What if everything you knew about the Earth was wrong? Since elementary school, we've been taught about the Earth as a giant sphere, spinning through space. But what if that was a lie? Imagine waking up one day to find out the Earth is actually flat. How would that change our understanding of the universe and our place in it? Buckle up, because we're about to take a deep dive into the mind-bending world of a flat Earth, exploring the science, the myths, and the sheer awe-inspiring implications of such a reality. Okay, let's address the elephant in the room, or rather, the gravity on a supposedly flat Earth. This topic has intrigued many and sparked countless debates. The concept of gravity is fundamental to our understanding of the universe, and it plays a crucial role in shaping the very fabric of our reality. We know that gravity pulls everything towards the center of mass. This is a principle that has been observed and tested repeatedly. It's the reason why when you drop an apple, it falls to the ground, and why planets, stars, and other celestial bodies form into spheres. That's why planets are spherical. It's the most stable shape under the influence of gravity. The spherical shape minimizes potential energy, making it the most efficient form for a body under the force of gravity. This is a concept that has been well documented and is widely accepted in the scientific community. Now, if the Earth were flat, gravity as we know it would have to behave very differently. The implications of this are vast and complex. For one, the gravitational pull would not be uniform across the surface. Instead, it would vary depending on your location on the flat plane. Instead of pulling everything towards the core, it might pull everything towards the center of the flat plane. This would create a very different experience of gravity. Objects would not fall straight down as they do on a spherical Earth. Instead, they would be pulled at an angle towards the center of the plane. Imagine that. Walking towards the edge of the Earth would feel like walking uphill. The further you move from the center, the steeper the incline would become. This would make everyday activities incredibly challenging and would fundamentally alter the way we live our lives. And what about the underside? Would things just fall off? This is one of the many questions that arise when considering a flat Earth model. The concept of an edge where objects could simply fall off into space is both fascinating and perplexing. The flat Earth model raises more questions about gravity than it answers. How would the atmosphere behave? What would happen to the oceans? These are just a few of the many questions that scientists and researchers have pondered. It just doesn't seem to fit with our current understanding of physics. The laws of gravity, as we know them, are consistent and reliable. They have been tested and proven through countless experiments and observations. The flat Earth model, on the other hand, introduces inconsistencies and anomalies that challenge our fundamental understanding of the universe. In conclusion, while the idea of a flat Earth is an interesting thought experiment, it doesn't hold up under scientific scrutiny. The spherical Earth model is supported by a vast body of evidence and aligns with our current understanding of gravity and physics. The more we explore and understand our universe, the more we appreciate the elegance and consistency of the natural laws that govern it. Let's talk about getting around. Navigation has always been a crucial part of human exploration and travel. From ancient mariners to modern pilots, the ability to find one's way has shaped our understanding of the world and our place in it. But what if the world wasn't the globe we know today? What if it were flat? On a spherical Earth, navigation is all about latitude and longitude, using the Earth's curvature to plot courses. These imaginary lines crisscross the globe, allowing navigators to pinpoint their location with remarkable accuracy. The curvature of the Earth is a fundamental aspect of this system, enabling long-distance travel and exploration. But on a flat Earth, things get tricky. Without the curvature, the entire system of latitude and longitude would be rendered obsolete. Navigators would need to rely on entirely different methods to determine their position and plot their course. The tools and techniques developed over centuries would no longer apply, leading to confusion and frustration. Compasses, which rely on the Earth's magnetic field, might behave erratically if they work at all. The magnetic field is shaped by the Earth's spherical nature, and a flat Earth could disrupt this delicate balance. Navigators would find their compasses unreliable, leading to potential disasters at sea or in the air. Pilots would have a tough time, as their current navigation systems depend on a spherical model. Modern aviation relies heavily on GPS and other satellite-based systems, all of which are designed with a round Earth in mind. A flat Earth would throw these systems into disarray, making air travel incredibly challenging and potentially dangerous. And forget about circumnavigating the globe. The concept of circumnavigation is based on the idea of traveling around a spherical Earth. On a flat Earth, such a journey would be impossible. Explorers would find themselves in uncharted territory, unable to complete their voyages as planned. You'd just keep going in circles, or maybe hit an ice wall, depending on which flat Earth theory you subscribe to. Some theories suggest that an enormous ice wall surrounds the edges of the flat Earth, acting as a barrier to prevent anyone from falling off. This ice wall would pose a significant obstacle to any would-be explorers. It seems like a flat Earth would make exploration and global travel a whole lot more complicated. The systems and tools we've come to rely on would no longer function as intended, leading to a world of confusion and uncertainty. Navigators, explorers, and travelers would face unprecedented challenges, making the dream of global exploration a distant memory. Chapter 3: Weather Gone Wild, the Climate Conundrum. Now imagine the weather on a flat Earth. Our current climate models are based on the Earth's curvature and its rotation. The Coriolis effect, which causes hurricanes to spin, wouldn't exist on a flat Earth. Wind patterns would be completely different, and ocean currents as we know them would cease to be. Would we still have seasons? Would day and night even work the same way? It's hard to say for sure, but one thing's for certain: the climate on a flat Earth would be a wild and unpredictable ride. Chapter 4: Houston. We have a problem: satellites and communication breakdown. Let's not forget about our communication systems. Satellites, which orbit the Earth and relay signals, wouldn't work on a flat Earth. They'd either fly off into space or crash back down to Earth. GPS, which relies on a network of satellites, would be completely useless. Global communication would likely revert to a system of undersea cables and ground-based towers, which would be much slower and less reliable. In a world increasingly reliant on instant communication, a flat Earth would be a major technological setback. Chapter 5. A world turned upside down: societal and cultural shifts. But perhaps the most profound changes would be societal and cultural. The very fabric of our communities would be tested as people grapple with new realities. Conversations in homes, workplaces, and public spaces would be dominated by this revelation. The shockwaves would ripple through every aspect of daily life, from the way we educate our children to the stories we tell each other. Imagine the upheaval if we discovered that everything we thought we knew about the Earth was wrong. The news would spread like wildfire, with media outlets and social networks buzzing with debates, theories, and reactions. People would be glued to their screens trying to make sense of the new information. The initial disbelief would give way to a mix of fear, curiosity, and excitement as the implications of this discovery began to sink in. Our entire understanding of the universe, our place in it, would be turned upside down. The stars, the planets, the very cosmos would be seen through a new lens. Astronomers and scientists would be at the forefront trying to piece together a new model of the universe. Public observatories and planetariums would become hubs of activity, filled with people eager to learn and understand this new perspective. Religions and belief systems based on a spherical Earth might crumble. Faith communities would face existential questions, as doctrines and teachings that have stood for centuries would be challenged. Religious leaders would convene, seeking to interpret sacred texts in light of the new reality. Some might find ways to adapt, while others could see their congregations dwindle as followers search for new spiritual guidance. New philosophies and ideologies might emerge to explain our place on a flat plane. Thinkers and scholars would delve into ancient texts and forgotten theories, looking for insights that align with the new understanding. Public lectures and debates would become commonplace, as people seek to reconcile their beliefs with the new evidence. This period of intellectual ferment could lead to a renaissance of thought, with new ideas flourishing in the wake of the old. It's impossible to predict the full extent of the cultural shift, but it's safe to say that it would be a time of great upheaval and transformation. Protests and public demonstrations would likely become frequent as people voice their fears and demands for clarity. Town hall meetings and community forums would be filled with passionate discussions as citizens seek to understand and influence the direction of their societies. But amidst the chaos, there would also be moments of unity and resilience. Communities would come together, supporting each other through the uncertainty. Acts of kindness and solidarity would shine through as people work together to rebuild and adapt to the new world. This period of transformation, though challenging, could ultimately lead to a stronger, more connected society. Outro: the Flat Earth Challenge, a thought experiment. Of course, the overwhelming scientific evidence points to the Earth being a sphere, a fact supported by countless observations. But the idea of a flat Earth, while far-fetched, serves as a fascinating thought experiment that intrigues many. It challenges us to think critically about the world around us, to question our assumptions and to seek evidence, and to never stop exploring the universe and all its mysteries, no matter how bizarre they may seem. What do you think would happen if the Earth was flat? Imagine the possibilities. Let us know in the comments below. We are eager to hear your thoughts.